So what if we don't care about who just wins first place? We also want to know first, second, third, fourth. So that's where ranking comes in. And we're going to deal with extended ranking. So extended ranking just means we're going to take the math that we've already done and use that to determine who's first, second, third, fourth. So looking back at lesson 1, we used plurality to decide who won. And so looking, we had A had 14, so they won. A had 14. B had 4. C had 10 plus 1 was 11. And D had 8. And so in that lesson, we just cared about who won. We were like, A won. But now we care about first, second, third, fourth. So who got first? A did. But now who got second? Well, it's the next largest number. So that's person C. Who got third? D. And who got fourth? B. So we're just going to rank them using the math that we already did. Alright, so looking over here at lesson 2, which is board account, we're going to extend it to first place, second place, third place, fourth place. So here I already put out the work that we had done. We determined that person A had 79 points, B had 106, C had 104, D had 81. So all we cared about at the time was the fact that B had first place, but looking at the math, we can be like, they had the second amount, they're second. They had the third amount, so they were third, and they had the fourth amount, that was fourth. Alright, so extended plurality with elimination was a little bit more difficult. That one was a little weird to look at. So we're going to do the math up here so that we can see what happened. So with plurality with elimination, we get rid of who had the least amount. So who had the least amount of votes? First place votes. Well, let's see, B had only 4. So we got rid of B first. So if we redid the math, B would have been gone first. So guess what? If B is kicked out first, they should be at the end. So they're last place. Alright, so these votes went to person D. So let's see who gets kicked out next. Well, D now has 12, C has 11, A has 14, so C gets kicked out next. So they are second to last. And now we're down to 2 people, A and D. A has 14, D has 10, 8 more, 4 more, 1 more. D won easily, and A only had 14. A was second. Alright. Now looking back at the math club election with pairwise comparisons, A had 0, B had 2, C had 3, D had 1. So we talked about how C mattered and how C had 3. But if we wanted to, we can be like, hey, B had 2 points, D had 1 point, and A had 0. So there's our ranking. First, second, third, fourth. So we're extending the math we already did to first, second, third, fourth. That's it. So here's a table of the math that we've done. And so we have, so using extended, right there, A, C, D, B. Then B, C, D, A. I wrote a 4 there. Extended plurality with elimination, D, A, C, B, and then we did C, B, D, A. So why do we make this chart right here? It's purely to show, look, A, who's first place? A, B, D, C. We had a different winner with different methods. And then if you look, A was sometimes first, sometimes last. B was sometimes first, sometimes last. D was first and third a lot. C was first, second, and third. I mean, it was such a wide variety of things with the different methods. We have another way that we could rank people, and that's called recursive. But we're not going to deal with recursive. But I want you to know that there is another one. Recursive. But we don't care. All we're going to care about is extended. And why don't we care? It's really not used in real life. Most people don't use this. They'll use this. So why do we need to deal with that? I don't know. So gone. You want to know some good test questions? Here they are. Here's a conclusion from all our 4 lessons. Elections are more than just for presidents and governors. It's for deciding where to eat or getting a job, or more. I mean, you could really use it for more. 2, there are many different methods to vote. We deal with 4 of them, but there are many different ways. 3, the outcomes from these methods can change with the different voting strategies. And we saw that through the math club elections. It illustrated 4 different winners with 4 different methods, and that's the idea. The last thing, number 4, is elections should be fair. They should be fair. They're not always fair. I mean, we want them to be, but they're not. But the idea is we want them to be. They should be fair. Should be. Should be. Not could be, not would be. Should be. Should be. The last thing is this. It seems like to be fair in an election, all the 4 criterions above should work. The weird thing though is it doesn't. It is actually mathematically impossible for that to happen. A person named Kenneth came up with that theorem where it is mathematically impossible to satisfy all those 4. And that concludes lesson 5.